Tere, hello. I'm going to talk to you about progressive delivery in Kubernetes and how to do Canary testing specifically very easily, and how this can help you develop things and deploy things with confidence, right? How to you deploy some new changes. There's some rules that will define if those changes are okay or not okay, and how these things can work together automatically and actually do automatic rollbacks. So I'm a principal scientist at Adobe Experience Manager Cloud Service. I don't do PDF, I don't do Photoshop, so not the cool things. We do some AI, of course. Everybody does, right? Who doesn't do AI today? And I've been a long-time open source contributor. Some things you heard: Jenkins, Apache Maven, Puppet. I started the plugin for Kubernetes agents on Jenkins, so that's one of the big things I did. So before we start, who has heard about Kubernetes? Raise your hand. Okay, all right. That was a question that. Even 5 years ago, not everybody would raise their hands. Who is using Kubernetes today? All right, fair share of people, good. So let's go into what is progressive delivery. Not a lot of people have heard about the term. It's a term that was coined in the Launch Darkly blog. This was 2018, right? So I think this was the first reference to the term progressive delivery. And Redmond is an analyst company that also picked up in the term, and I saw it and I was like, that's perfect. I'm going to steal the term also. I'm going to talk about it. It's a term that includes nothing really new, but it gives a nice name to a bunch of techniques that already existed. So how to do deployment strategies that avoid this all or nothing delivery. So you deploy something. You don't want to update everybody. At the same time, you want to progressively figure out, is this okay, is this not okay? Because if you break something, you break everybody. So you try to do something more progressively. That's the beauty of the term. So you do not replace existing versions, but you run them maybe in parallel for an amount of time. You do this live. I think this is the key part of the concept, is that you do it in production. You receive a specific amount of traffic for an amount of time, live production traffic, and then you figure out, is this correct? Is this performant? Is this successful? Is it not? And sometimes it's easy to figure out if something is good. Sometimes it's a bit harder to figure out if, for instance, I don't know, you drop a 1% on performance. That may be a horrible thing for some companies. For other companies, it might be okay. And it's also hard to measure. But I think the key part is you can do this in production. So continuous delivery is hard, but progressive delivery also tries to make continuous delivery easier to adopt in a way that reduces the risk associated with continuous delivery. You make a change, you commit something, you have everything automated. Who doesn't, of course? Everybody has everything automated all the way to production. And then now you realize, oh, I broke something. I didn't have the test that covered that corner case, or it's only broken for some specific customers that are doing something strange. So progressive delivery would both reduce the impact and could also automatically mitigate it. So the three key points is avoiding downtime. So your service is not down for everybody when you make a mistake, and everybody makes mistakes at some point. Limit the blast radius. So if you make a mistake, how can I make sure that this doesn't affect everybody? This only affects a small group of people, as small as possible. And also, because you have these safeties or these guardrails in place, it allows you to move faster and do more changes with this safety net. The techniques for progressive delivery, a lot of them are already well known. So you have rolling updates, and this is an example of what Kubernetes does. when you make a change to a deployment, it will start a new pod with a new version of your image, of the changes you have done. And you're going to have both running. When one comes up and is ready, an old pod gets deleted. And then so on. If you have 5 pods, it's going to do this like 5 times. If you have more, it's going to also do it. I mean, there's a percentage. Kubernetes does a percentage, so it's not always one by one. If you have 100 pods running, and pods containers, right? You are not going to have 100 new pods running at the same time by default. You're gonna it's going to start a few of them. I don't remember now what was the default percentage, but imagine it's 10 new pods start up, they're ready, 10 old pods are deleted, then 20 new pods, and 20 old pods are deleted, and so on. This is, of course, all configurable. In fact, you can do it just in one go. You could configure it in many ways. But that's the idea, the default deployment strategy on Kubernetes. Rolling updates. It existed before with VMs, people, and even with bare metal hardware. People go update a new one, delete an old, or rematch one VM or one server, and then one by one, so you don't kill everything at the same time if you make a mistake. Blue-green deployment. So this is the idea that you have a version 1. I never know if what is the big one is green or blue. Doesn't matter. It's you have a new a V1, then you deploy a V2, and at some point you point your DNS, load balancer, whatever it is, to the new version. The problem of blue-green deployment compared to rolling updates, for instance, is that you need to have twice as many infrastructure. So that's why it's not so popular, especially for big services, because you need to have both running at the same time. Maybe you can mix this with auto-scaling, so you don't need as many. But the idea is old version, new version, I change my load balancer to the new version. If something breaks in the new version or I realize there's some troubles and I watch for it, then I point the load balancer back to the old version and my downtime is limited. It's not like I have to go and start the service again, the old service, to go back to the V1 version. Canary deployment is kind of a mixture where you send a percentage of traffic to the new version. So you start with sending, I don't know, the typical use case is you send internal traffic first, like your own developers, employees, or whatever, to the new version. Then you send a 1% of the customers, or then 5, 10, 20, whatever the right number is for you. Or maybe even by regions. You can send, I don't know, European customers to the new version. You could send, do whatever you want. You examine the traffic. You see if that section of people are getting a successful version or a successful application, whatever your successful metric is. And then you can increase how many people are getting the new version until you go up to 100%. With the idea that if you, for whatever reason, you realize something is broken, you just have to drop these percentages and everybody goes to the old version. Yeah, typical cases, you do this with load balancers. You can do this with HTTP headers, geolocation. You can do it also with, I forgot. I totally forgot. Anyway, you have multiple ways of doing the selection at the kind of the load balancer of whether one request, and typically for web services, whether one request goes to the old version or the new version. There's also feature flags, which is taking a bit of the next level, where you can enable or disable individual features in your application. So you can say, okay, I'm deploying a new version that has the ability of doing something new, But that's turned off by default. And by just changing something through an API or through some other way, there's commercial tools also. There's actually a project from the Cloud Native Foundation that kind of tries to standardize how to do feature flagging. Through some mechanism, you enable that. Imagine you have an if-else in your code. If the flag is enabled, you do something. If the flag is not enabled, you do the old thing. So you can say, OK, I'm going to enable this new feature. I see how people are interacting with this new feature. If I detect that something is broken, I just disable the feature. And that change is typically very quick or immediate. So this gives you the flexibility of detached deployment from business case deployments, right? You have a business case that you can enable or disable based on business reasons more than just code. And then you can combine things together. You can do feature flags with canaries. That's also very popular, where you say, I want to enable this feature flag, but only to a percentage of my users. Or I want to enable this feature flag for everybody, and then, for these customers is broken, so I'm going to disable it for them, but I can continue figuring out for the next release what was the problem with these customers. So it's a way to have a safe, very fast option to turn off things when things go wrong. I like to say that monitoring is the new testing, in the sense that you know when users are experiencing issues in production, and you can react with the monitoring, you can react to the issues automatically. You have some metrics, you can act on those metrics, you can have rules that act on those metrics. And yeah, progressive delivery requires a good amount of metrics for this reason. And I like this quote from DevOps Borat on Twitter, that to make error is human, to propagate error to all services in an automatic way, that's what DevOps is. And it's not the first time that I personally have deployed something and then realized, oh shit, was too automated and now everybody's broken. So progressive delivery is trying to avoid that. And something that I like to say is, if you haven't automatically destroyed something by mistake, that means you are not automating enough. I mean, you have to push yourself to automate things, and then one day you realize, oh shit, this was too much. Okay, and I broke something, so you gotta step back. Now, progressive delivery on Kubernetes. For those of you that are not so familiar with how Kubernetes services work, typically you have a load balancer outside of the Kubernetes cluster if you run on the cloud, because everybody runs on the cloud, right? You have services that are fronting pods. Pods are sets of containers. So you have your service running on these containers, which are grouped in pods. Then a service is also like a load balancer, software load balancer. And then you have the incoming traffic through the external load balancer, then goes into the service, and then into the pod container. So that was the typical use case. Now, there's also the ingress, Kubernetes ingress architecture, where you have an ingress controller, which is something like a load balancer, but it's living inside the cluster. And it can do more advanced routing based on host names, paths, things like that. Now, the traffic with the ingress model, you get the traffic, and then the ingress controller decides which service to send the traffic to. And you have a bunch of implementations of this ingress controller. It's an API that is implemented in the different clouds. They have their own ingress controller, AWS, Google Compute Engine. Nginx is typically, you just have Nginx, and it's automatically getting configured based on the services you create. The whole ingress controller is based on Kubernetes resources. So every time you change that resource, then the ingress resource, then the ingress controller gets reconfigured. Ambassador, Istio, traffic, it's a proxy. There's a lot of them. And it depends on your use case which one you want to use. And Istio, for instance, is a service mesh. Service meshes became very popular. Now they're losing a bit of popularity now. But then the service mesh allows you to do more advanced networking setup, like sending percentage of traffic to different places. And you can have ingresses like the Istio one that will allow you to do more fine-grained traffic management. And enter the world of Argo rollouts. Anybody familiar with Argo? Oh, Argo CD. Argo CD is very popular, and then there's Argo workflows, and there's also Argo rollouts. The interesting thing about Argo rollouts is that it's totally separate from Argo CD. You don't need to use Argo CD or any of the other Argo tools. And the demo I'm going to show you, it's not using anything else. So it's a standalone project and provides advanced deployment capabilities. It allows you to do blue-green, Canary analysis, experimentation, and all these progressive delivery technologies. So you configure Argo rollouts, and then it takes over your deployments in Kubernetes, and it will, depending on how you configure, is going to do one approach or the other. The way it works, let's see here. You have the rollout controller in Kubernetes, and you have an analysis template that's at the top. The analysis template is what defines. This would be for Canary analysis deployments. This is what I'm going to demo because I think it's the most interesting one. The template is going to say what does a successful deployment means, a successful rollout. What metrics do I need to look at, and what's the limit on those metrics, and so on. So when you have traffic coming from the left, okay. No, it doesn't show anything. So you have traffic coming from the left through the ingress into the service, and then the rollout is going to manage 2 replica sets. This is a Kubernetes concept also. The replica set is typically used with deployments, but now the rollout takes over and has 2 replica sets, one for your stable version and one for the Canary version. The Canary version is the new one that you are deploying. And so it scales up the Canary replica set depending on your, however you define this rollout to be configured. And you have both the old pods and the new pods, and it's changing increasing the new pods and decreasing the old pods based on whatever you configure. Then it executes the analysis run, and based on that execution, by looking at the metrics, and it decides whether it's successful or it's not. If it's successful, the Canary keeps rolling up until it gets to 100%. If it's unsuccessful, it's going to do an automatic rollback. So that's the interesting part. If I make a mistake and my metrics catch this mistake, my rollout is going to be automatically rolled back. I don't have to be watching. And for metrics or analysis, there's a bunch of options to configure Argo rollouts. You have Prometheus typically for metrics, but then there's a bunch of other options. Of course, this requires an amount of YAML configuration, and that's the preferred tool for coding with YAML. Yeah, this is a bit what I explained. You have the initial version. All the users go into the load balancer and into your application. And as you move towards the rollout, then you get more and more users getting into the new version. So I have my application running, and it's returning blue colors, and I'm going to watch it here. Right, I have my application. My application is returning blue, and I'm going to do a deployment. And on the right-hand side, you can see a bit of, I have 10 pods running on the stable version. And I'm gonna do a kubectl Argo rollouts was set image, and I'm gonna set it to green. Okay, and we see how there's now a canary. Let me make it this bit bigger without breaking everything. Okay, so now you see there's a canary that has 2 pods running. For now, there's 2 pods, and you see here on the application that I'm starting to get green squares. So that means a percentage of my traffic is going to the new version, which is green. How I define my rollout is to make a stop on the 20%, and it here says post at the top. So I can go and do a manual promote. This is something that you could do if you want. Argo rollouts. This is promote. Oops. Argo rollouts. That's not promote. Oh yeah, it's promote. Promote. And is Canary, what was it called? Canary demo. Yeah. So I'm saying, okay, my application looks good, just keep going. And now it's gonna go through all the different steps. On the set weight, actual weight at the top, it tells me, okay, now I'm 25%, and it's gonna keep going. It's gonna keep increasing the number of new pods and decreasing the number of old pods until, and then doing analysis. On the blue line is the Canary demo analysis, and it's analysis run, it says running, so it's checking continuously as it continues growing the number of pods, it's checking that, they match my success rate. And I think this may be too fast. And then now its set weight is 60%, actual weight 50%. So in a few minutes, this, well, in less than a minute probably, this should be all green. Okay. And now, okay, this is 75%. I'm getting more and more greens. At the bottom, you see how many greens I'm getting, and that should be done in a second. When this is finished, what Argo rollouts is going to say, okay, the Canary becomes the stable. I'm killing the stable. We're done. I'm killing the stable. Now the Canary becomes the stable, and we can continue going. I can deploy another change, and we go through the same process again. Okay, the Canary became the stable. Everything is green. My rollout has been successful. So, and only a few customers were experiencing the new version as doing requests. Now, if I go and say, I do a bad deployment, red, nice, bad red. I'm gonna do a new deployment. I'm gonna change the image to an image that is red, but is returning errors. So I should be getting some reds here, yes? And on the right-hand side, I can see my Canary is happening, and I set it up so the analysis took a little bit to start, so I can show you. So now I'm getting some reds, and I'm imagining, okay, this looks good. I'm gonna do the promotion again. And just because I'm doing it manually for the demo, but ideally you would not have manual steps in here. So the rollout continues progressing, and is now 40%. The analysis run, it's set here, successful. Okay, it should be running again. Okay, did I mess up something? Maybe I did. It's always the demos will never work. Maybe it happened too fast or something, and the analysis finished, or I was too slow. Okay, no, everything looks fine from its point of view. I did something wrong. It's always the operator's fault. So let's say bad yellow. Let's try again with bad yellow one. Yeah, what happened here is that the analysis run ended before I probably did the promotion. So I'm gonna do a yellow one, and now let's promote it quickly before the analysis finishes. Okay, I'm getting yellows. The analysis run is now running. It's paused. Okay, now the analysis run, it shows us failed here. On the right, there's a red thing here that says failed. And we can see that the yellow deployment, the last one I did, was considered a failure, and it went automatically back to the red one. So if you set the right analysis, then you're getting this, right? Automatic rollbacks. Sometimes it's a bit tricky. Some issues we had as we deploy this at my team in Adobe was like how to figure out what are the right metrics for a successful or not successful. An obvious one is the number of 500 errors you are getting, right? You could say, if I'm getting more than 10% 500 errors, then it's a big problem. But maybe for a customer, 10% is too much. For other customers that they have testing environments, then 10% they don't care. So it's always figuring out what the right metric is for the job. Imagine you have a shopping cart web application. Maybe your metric is, if nobody's adding things to their shopping cart, something is very wrong, and we're missing in money. Because you don't know what's happening, but you know people are not adding things to the shopping cart, so something must be wrong, right? And on the right, I see the rollout is marked as aborted. It says the metric success rate failed, and scale down the Canary, it marks it as failed, and the stable is back to the red one. So that's pretty much what Argo does it. It's very easy to do. It's mostly figuring out what these metrics are. That's a bit tricky sometimes. 500 errors, whatever is the makes business sense for you. And I think with that, if oh, I didn't show you you also have a web UI where you can see everything that I was showing you. This was my steps. I was putting wait 20% and then a pause, then 40%, 10 seconds, 60%, 10 seconds, 80%, so on. And I can see how many pods I have it running, and I can see here revision 9 was good. We are running on revision 9, and revision 10 is bad, and that was the Canary. And you can do manual things here if you wanted. The whole point is to have it automated. Okay. So with that, I can have some questions. Yeah. Thank you. Ask me one question. Yes. Yes.
Am I audible? Yeah. How Argo analysis decide the container is not healthy, or what checks we are doing? Like, let's say one of the API is not working with the problem with the app. Like, how it decide it is red and rolling back?
The red color is just my application. My application is giving you the colors. The success rate is measured with, in this demo, I just was doing a curl to check for what results I was getting. But some other examples is you go to Prometheus and you query Prometheus and you set whatever Prometheus query you want to do. And then if you say over there at the top is if the result is over 90%, then consider it failure. Sorry, or the other way around. But you have to tell what means is broken. Kubernetes will automatically, if something is very broken, like your container image is not starting or not exist or something like that, Kubernetes already will stop that for you. This is more on the higher level of what does an application success mean.
Okay, it ups to me. Out of the box solutions we have automatically, and we need to also decide what is fail for us. Then it will fail. Okay.
Yeah, here you have to tell what is success for you. Yeah.
Thank you.
Thanks.
Hi. You had a slide with a computer screen that was covered by a wooden ruler or something like that.
Yes.
Could you go back to that?
Okay.
Yep.
This
one. What's going on here?
You definitely never work with YAML, did you? No. Okay. I guess the people that work with YAML understand this immediately. With YAML, and this happened to me a bunch of times, and you will hear all the complaints. If you make an indentation mistake, one space more than another, it's broken, and you may not notice until you figure out where the problem was. So yes, I guess yeah. If you haven't worked, this is a very internal job for people that have used YAML.
Thank you.
All right. So, well, hopefully this show you how you can practically do the Canary deployments automatically with automatic rollbacks, and maybe something that you want to take back home and play with it. All right? Thank you.
Thank you. Just to check, is it really that no one else has a question?
Yeah, we have time, right?
Actually, yeah, we have some time.
Or you can find me later. Fine.
Yeah. Oh, okay. So then the final question from me is that which are the 5 most important Kubernetes-related terms every tester should know by heart?
The terms. I don't know. So I think there's still, even if we work in the whole stack, there's some things that people know better than others. We have the issues with Kubernetes, for instance, for low-level DNS problems, nodes, kernel issues, and that requires a lot of operational knowledge. Then you have people that are more into the application side, and then they have to understand how Kubernetes is deploying your application. What does it mean? A typical mistake or questions that happen are readiness and liveness probes in Kubernetes. Kubernetes by default allows you to kill a container when it fails some metrics. This is the liveness checks. And also it allows you to take a container out of the load balancer if it's failing the readiness check. And people mistake them a lot. So imagine your application is totally broken. You want to emit something that Kubernetes checks and says, okay, this container is broken, I'm killing it and restarting it. Maybe you have overrun with memory, an issue like that, and restarting helps. And then you have other occasions where, oh, I'm getting too many requests, I cannot handle more, don't send me more requests. That's the readiness check. And you say, I'm not ready to handle more requests. So a typical mistake that people do is setting both to the same thing, and they're totally different, right? If you are not ready to receive more requests, restarting is not gonna help. It's actually making things worse. So that's one more on the application layer of it. For testing, there's a bunch of ways. We do, at my team, we do cloning of environments. So you take the Kubernetes deployments, you clone them, you run things there. And I forgot to mention, with Argo rollouts, you can also do traffic splitting. So you can have 2 versions and getting the same traffic in both versions, and you can test that the new version is working with live traffic before even any customer sees that. So I think Kubernetes abstracts a lot of details, but if you have issues, you have to go deep down, maybe. But yeah, it's complicated, but it's making things more standard, I guess.
Thank you. So once applause more, please.
All right.